my name is Julian Lopez. This is the product rule. When you have the derivative of x times g of x, it equals to f prime times g plus f of x times g prime. So we're going to let f of x equal fx times gx, and so now we're going to prove our product rule. So we have f prime equals to the limit of f of x times f of x plus h minus f of x over h as h approaches 0, and then this simplifies into the limit of f of x plus h times g of x plus h minus f of x times g of x over h as h approaches 0. And we want to separate the two functions of f and g, so we need to add and subtract f of x plus h times g of x. So then that's when we get this larger formula, our function of the limit of f of x plus h times g of x plus h plus f of x plus h times g of x minus f of x plus h times g of x minus f of x times g of x all over h as the h approaches 0. Then we bring it forth in separating f and g. So we have the limit of g of x times f of x plus h minus f of x over h plus f of x plus h times g of x plus h minus g of x all over h as h approaches 0. And there we distribute the limit to all of these, and then we get the limit of g of x as h approaches 0 times the limit of f of x plus h minus f of x over h as h approaches 0 plus the limit of f of x plus h as h approaches 0 times the limit of g of x plus h minus g of x all over h as h approaches 0. And putting it all together, we get the wonderful final product of f prime times g of x plus f of x times g prime.
Hi, Dr. Chang. This is the quotient rule video. So we know the quotient rule is applied if f and g are differentiable. Then we use the derivative of f of x over g of x equaling g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. So we're going to try to prove this. So we're going to let f of x equals f of x over g of x. Then we're going to have f prime equals the limit of the function of f times x plus h minus f of x all over h as the h approaches 0. Then it breaks down into the limit of the function of f of x plus h over g of x plus h minus f of x over g of x over h as h approaches 0. Then we have the limit of the function of f of x plus h times g of x minus f of x g of x plus h all over all over h g times g of x plus h times g of x. So we can separate f of g in this expression by subtracting and adding the term f of x g of x in the numerator. So by doing so, we get f prime equals the limit of the function f of x plus h times g of x minus f of x times g of x plus f of x times g of x minus f of x times g of x plus h all over h g of x plus h times g of x. And then continuing on to that, we have the limit of the function g of x times f of x plus h minus f of x all over h minus f of x times g of x plus h minus g of x all over h, and all that all over g of x plus h times g of x as h approaches 0. Then we get the limit of the function of g of x times the limit of the function f of x plus h minus f of x all over h minus the limit of the function f of x times the limit of the function g of x plus h minus g of x all over h, all the numerator divided by the limit of the function g of x plus h times the limit of the function g of x, all as h approaches 0. Therefore, arriving to g of x times f prime minus f of x times g prime of x all over g of x squared.